Hey guys, so here's part 3 of the 5.6 notes. We are once again going to be using our synthetic division to find the zeros of our polynomial. Now this was a little bit different than our first two examples because now our leading coefficient is not 1. So that means when we do our synthetic division and we get it to our quadratic, it is possible now that our leading on that quadratic will not be 1. So let's go ahead and do this. So they've given us the 0 of 2. I'm going to draw my box now. And so now I use my coefficients. I do start with an x cubed, so that means since this is in standard form, our degree is 3, meaning we will have 3 solutions because of the fundamental theorem of algebra, which you guys, we learned about and talked about in our 5.4 day 2 notes. So when we started solving polynomial equations by factoring. So we start with a 2, then we go to a 5, a negative 11 because that's the x term, and then negative 14 because that's the constant. So since we do not have any missing terms, we do not use 0 as a placeholder. So now what I'm going to do is I take the first 2 below the horizontal line, and now I multiply anything below it with the 2, so that gives me 4. Now I do some vertical addition, so this gives me 9, and then 2 times 9 gives me 18. And so I do negative 11 plus 18. That gives me 7. And then 2 times 7 gives me 14. That I get a 0, which I should always get 0 as the remainder when they always give you a 0. Okay, so now remember we always go down 1 degree. So now I go down to x squared. So I have a 2x squared plus 9x. And then plus 7 equals 0. So now here we have multiple ways of solving. Once again, we can either factor or use the quadratic formula. I'm going to go ahead and factor this just because it's been a long time since, or been a while since we have factored when the a value is not 1. If you rather try to use the quadratic formula to see if we get the same answer, which we should, you can do that as well. So remember, when we're factoring when the a value is not 1, we need to find the numbers that multiply to 7, which we know is just 1 and 7, but we also need to find the numbers that multiply with our leading coefficient. So that's going to be 1 and 2. So now we have to find the perfect pairing that when we multiply will give us, and we add up, will give us the 9x. So I definitely, because 2 only has 1 pair, I have to use 1 and 2. So I'll definitely have to have an x and a 2x. Now that's going to be the same here, like I have to use 1 and 7. So I'm going to go ahead and put 1 here and 7. So in order to add up to this 9x, what I have to do next is I have to multiply my 2 inner, so that gives me 2x, and multiply my outer, so that gives me 7x. So if I added 2x and 7x, or subtracted, could I get 9x? Yes, I could. So both of these have to be positive in order to add. So I have positive, positive, and I know if when I multiply the last number, so a positive 1 times a positive 7, that still gives us a 7. Okay, so now I'm going to set both of these equal to 0, so our factors, and solve. So I have x plus 1 equal to 0, and then 2x plus 7 equal to 0. Okay, so I move the 1 over, we get x equals negative 1, so that's one of our solutions. Remember, don't forget the 0 they gave to you, which in this case it's 2, so x equals 2. And then here, I'm going to move the 7 over first, so I have 2x equals negative 7, and then divide by 2, so I get x equals negative 7 halves, or negative 3.5. Okay. There we go. And so, as we said, we should have 3 solutions since our degree of the polynomial is 3, and we do. So we did this correctly. Okay, make sure you guys work on the homework assignment. If you do have any questions, make sure you contact me. I'll see you guys later.